So what happens if it's unbalanced, basically? Unbalanced consumption, one of them is going to produce a result quicker, and the other one will just keep running. It's only when both of them finish that it's going to exit.
Is this a safe way to consume from upstream? For example, if upstream stopped yielding results, would it break? Would this implementation break?
If upstream does stop producing at some point in here.
But I guess if it throws a failure, it would handle that in some other area, right? Okay, fine. Generally speaking, in a conduit pipeline, if one of the components throws an exception, the whole thing goes down. There's no, you can set up your own exception handling within a component, but generally speaking, the default, once an exception gets thrown, they're all going to disappear.
If you replace one of them with take 10, or take say 10 inside it, you just take the first 10 of it, would it keep zipping the two together, or would it stop it? Not 10, if 5. If we went ahead and we did take C5 together with the sum, then this one is going to stop consuming any values after the first 5, and it's just going to sit there and do nothing. The other one is going to keep running. So it's only going to have one piece of the pipeline continue. So you'd actually get kind of a weird answer there, where it's sum the first 5 and divide by 10.
Yeah.
Is there something like a fork?
You mean you're asking fork like a concurrency thing?
No, more like I have 5 equal data. And split it into 2 and process them in a different way.
I think I know what you're talking about. Yes, there is. Zip sync is the most common one. There's also a zip source and a zip conduit. And those are less common, but they can be used for the kind of, I want to send some, like, I have a stream of either values, and I want to send all the lefts here, and I want to send all the rights here, and I want to do something. Yes, you can do that.
It's kind of continuous, right? Because you can split it with the zip syncs, but I kind of want to continue doing those extra processing. Right, so.
Yeah.
Okay.
Yeah, there is a way. It's more common. It's not nearly as common, which is why I didn't include it here. Okay, so takeaways from this: when you have the applicative or the monadic composition of two components, they sequentially consume from upstream. The first one consumes everything it can, everything it wants to consume, and then the next one consumes everything it wants to. Zip sync is the thing that allows them to consume in parallel. By the way, we didn't look at it, but you can also sequentially produce to downstream. So you could take 2 source files, stick them together, and you have now produced a stream of the contents of both files. Yeah?
Are those interleaved in that case, or
No, it's going to go entirely through the first and then entirely through the second. If you want some kind of interleaving of a source, then you use zip source. But that, in the case of a source file, that would be very unusual. Yeah.
One of the questions I've been thinking about with this whole thing, and I'm sure you're going to give me a great answer, is
I hope.
My very first step in the pipeline is I have a very I/O expensive operation. And my second step is I have a very expensive computational operation performed on the result.
Yeah.
Is there a way to do both in parallel? Like to be pulling the I/O resource while I'm doing the CPU computation?
So can you do?
Steps.
Can you do 2? So the basic way the conduit works is that only one thing is going to be running at once. You're really getting into, can you do some kind of a concurrency thing, which is what Chris was asking about earlier, and I'll get to in a second. Okay. Basically, within the world of Conduit, no. Okay. Conduit is by its nature single-threaded. It's coroutine based, and there's only one thing running at any given time.
Another thing is that, okay, so with ZipSync though, like since you have 2 things or more running in parallel, might you also run like a space issue there, like where like one is proceeding faster than the other or something?
No, you can't run into that. Each one of them will be in lockstep. So this one will keep running.
One will block the other.
They both block until both of them are awaiting again. Okay. It's actually a funny question that you ask. We're not talking about zip conduit right now. Zip conduit is something that allows 2 things to process and produce in parallel, and you actually get into that kind of issue there. And that's why zip conduit isn't nearly as easy to use as you would think so, because it has to avoid that memory leak.
Yeah, okay.
Yeah?
You may want to, sorry, I messed it up. Is there a way to sort of parallelize this and use several computers as part of the...
I'm actually having trouble hearing you. Could you speak up a bit?
Is there a way to sort of parallelize it? You have part of the Conduit pipe
That's,
One computer.
yeah, we're-
That's the question, right?
yeah.
Then with 14.
yeah, we'll get to that in a moment. Okay. Let me actually just look. Oh, let's talk about concurrency now. Everyone wants to hear about concurrency, so let's talk about concurrency now. So you have to, if you want to do concurrency with Conduit, you want to have two different things working at the same time. How do you do it? A common example of this would be that you are talking to a network client or a network server. Yeah, you're doing some kind of network operation and you've got a socket. If you have half duplex communications, where either one side or the other side is going to be talking at any given time, no big deal. You can just do the whole thing in one conduit pipeline because you're only ever going to be running one kind of operation. You're either going to be waiting for the server to send something to you or sending something back to the server. But what happens if you have something like a WebSockets connection? And you're going to go ahead and be waiting, let's say you're the server in that case, and you could be waiting for the client to send you some data, or at any time you may want to send some kind of a packet downstream to the client. You can't do that in a single conduit pipeline. It's impossible. The way you have to do that is you have to use concurrency. So you can go ahead and you can fork two threads. Don't actually use fork.io. Use the async package because async is awesome. So you can use the async package and you can go ahead and have one of them doing the reading, one of them doing the writing. You may wonder, how do you handle the communication between these things? The fact is you have to use the standard concurrency approaches like STM. That's the way you would do these kinds of things. So if you want to go ahead and do some kind of I want to get this thing started, I want to run this in the background, you're basically going to have to use some kind of fork.io. You may want to go ahead and have this, one of the expensive computations feeding into a channel, and then you can use Conduit for this. You can have Conduit using the STM Conduit package. You can have one expensive thing running in one thread, feeding into a channel with a sync, I think sync chan is what it's called, and then you can have a source chan on the other side, pulling it out, and these things running in different threads. So that's basically the way you would do it. So Chris, you were asking, did you have a specific kind of question about how you would do these things?
Yeah, I don't know if we can address compactly. So we use pipes concurrency for processing clickstream.
Okay.
The ad tech company I mentioned.
Yeah.
And we started trying to build up almost like a mini cloud Haskell, but even just the concurrency part sounds like it's kind of difficult. If I wanted to get Conduit to parity with something like that.
So I don't know Pipes Concurrency's API well enough to comment on exactly doing that, but we can go over it later. And my answer is almost certainly going to be, you're going to use STM for all of the hard stuff, and then you're going to do the easy stuff with Conduit. That's probably what I'm going to say, but we'll see. Okay, so just a few more examples. Actually, we're getting a little late. We may want to just go ahead and jump into the Yesod stuff. So I'll breeze through these. You guys can also play around with these, run them yourselves later. So you can see you've got pure folds. This is the fold LC. This is just going to go ahead and create the same list that was sent into it. You can have monadic folds, where we're going to go ahead and we're going to print messages in between, and we're going to sum them up. Someone out there may be wondering why I don't need like a strictness annotation here, why I'm not doing bang. All of the fold operations in Conduit are strict by default because it wouldn't make sense to do any laziness here. It would never be a good idea. Okay, what's wrong with this type signature? To give you an idea of what we're trying to do, we're going to receive a stream of bytes. We want to figure out how many of each byte exists. So we're using a hash map to track this, and every time we receive an incoming byte, we are going to insert it into the map. If it already exists, then we're going to add 1. Otherwise, we're going to set it to 1. What's wrong with this type signature? By the way, the title might be a clue. No, the output's fine. The output is a type variable. It can be anything it wants. So that could end up being void, but that's not necessary. This is actually just an efficiency problem. Conceptually, there's no problem with this. Efficiency-wise, if you're reading a file that has, I don't know, a kilobyte of data, then you're going to be going through this 1,000 times. I mentioned way earlier that we have heap objects for every single step through a conduit pipeline. That's a lot of heap objects. By contrast, a byte string could hold all of that in memory in a single chunk, and you're going to trigger conduit each time. Point being, whenever you're dealing with these kinds of this kind of data, you want to chunk it together into something like a byte string, or text, or vector, or something like that. So it's very common, in fact, to see conduits based around byte string, because oftentimes we're dealing with raw data that's coming out of a socket or a file. What I want to point out here is the change that I made to the program. Over here I had fold LC. Here I have fold LCE. E here stands for element. We are going to be running this fold not on the data itself, not on the byte string itself, but on the values inside the byte string. And the values inside the byte string are the bytes. It's the word 8s. This does exactly the same thing, but it will do it a hell of a lot faster. This is way better. The signature is actually more generalized than this. If you actually care, you can look at the monotraversable package and to understand what's going on there. But the point is, this is the way that you want to be writing your code. And the Conduit Combinators package provides this dual API for chunked and non-chunked data so that you're able to easily go ahead and do these algorithms in a chunked way. Okay. Yeah.
Did you work on even a algebraic data structure you were reading in earlier?
If it has a monofoldable instance, then yes, it could. Yeah, it could look at anything like that. Basically, it's and depending. There's also monotraversable. There's a few other things, but basically, if you're going to go ahead and run a fold on it, it can, as long as you're able to fold over that data structure, it'll work. Yeah.
Does Fold say have some predefined chunk size?
Fold. No. Oh, that's a good question. So, does fold L have a predefined chunk size? No. Source file has a predefined chunk size. Source file is going to determine the size of the chunks, and those chunks may be very wildly differing in size because as you go through the pipeline, it might get modified. You might break it up into multiple pieces, so you can't actually rely on any specific chunk size. You just have to go with the flow, with whatever you get. Yeah.
Is there something that will give you an index for each element as it goes through the pipeline? Kind of like I'm thinking of like Python's enumerate.
You want to give it an index each? Yeah, you could. Yeah, you could go ahead and you could write something like that. Yes, you could write a map function that would do something like that. Okay. Okay. I think this is the last concept we have to cover for Conduit: leftovers. And anyone who's seen the discussions around Conduit, leftovers is one of the most controversial topics, but one of them that is absolutely in the package. This isn't a trick question. It just is getting you set up for a trick question. What is this output? So I am going ahead and I'm yielding the values 1 through 10. And then I'm going to first take all the values that are less than 6 and put them into a list. And then I'm going to take the rest of the values and put them into another list. What's the output from this? Well, it's the numbers 1 through 5 and the numbers 6 through 10. And you're probably thinking, Michael, you're crazy. Why would you even bother asking me that? Of course, it's got all the numbers. Let's try to implement TAKEWHILEC ourselves and see what happens. So this looks like a pretty straightforward implementation. We're going to loop, and we're going to wait for a value from upstream. And if there's nothing there, we're done. And if there is something there, we're going to check if the predicate passes. And if the predicate passes, we're going to send it downstream, and we're going to loop again. Otherwise, we're going to stop. And if you look at this output, it goes 1 through 5 and 7 through 10. Say again? I can't hear you. You need to peek, right? But hold on. So we dropped the 6. Who can see where we dropped the 6? Which line of our function dropped it?
That last line is return.
The return. So we got a 6 here. It failed, and we didn't do anything with it. So of course it's gone. We don't want it to be gone, but of course it's gone. There was nothing else that our code possibly could have done. So how does the real TAKEWHILEC actually hold on to that value? Because we already saw here that the output was correct, unless I'm just lying to you and I'm putting up, fake output, which is possible. I do lie to people. Thank you for someone laughing. Okay. Let's fix it. You were right. The return unit was the problem, and we use leftover x. Leftover says, I got a value. I awaited for it. It came from upstream. I don't want it, but maybe somebody else does. Remember, we were talking about monadic composition, allowing the next thing in the pipeline, the next thing in the component, to go ahead and consume the rest of the stream. This puts something back on top of the stream. So you can go ahead, you can grab a value, and you can leftover it. Mark had said something about peek. You can peek at the top of a stream. Grab a value, look at it, and leftover it. This, I think, is the most complicated example that we have in these slides. So let's have fun with it and make sure we understand it, and then we get to play with web programming. So who wants to walk through this and try to see what the output is going to be from this program? Firstly, where are we going to start? What's the first line that's going to get executed? Leftover? What else? Who had another idea? Print C. It's going to be leftover, sort of. It is actually going to be leftover. But that's not actually going to produce any kind of output. We're next going to hit print C. What is print C going to do? Say again? It's going to await. Where is it going to await for values from? It's going to await from maps. It's going to await from upstream. However, our leftover puts something in the queue ahead of the rest of the stream. So it's going to grab that first. So the first thing that's going to happen is we're going to grab hello there and print it out. Next, we're going to await again. And at this point, there's nothing left in the leftover queue. So now we have to go upstream. Now we go to this component. We're going to jump into mapCID. mapCID is first going to do what? Who can guess? Await. Very good. It's going to await, because in order to map over something, you have to have something to do, to work on. So it's going to await. It's going to come up here. Yield many is going to give us a 1. mapCID. So it's going to take the 1, it's going to give back a 1, and it's going to send it downstream. Where is it going to send it downstream to? To where? Await C. So notice how we've now made this complicated composition of different things. We're now going to be sending data here. So await is going to get that 1, and we're going to call leftover. Where's the leftover going to go? It's going to go on the queue. Whose queue? This, by the way, this is the most complicated part, so don't be worried if it's confusing. Say again? We wish it did. It doesn't. If, right now this is ID. Imagine that this was a show instead. We've changed types. So we would like it to be that 1 is going to go down to print C, but there's no way that we could do that in general, because this may no longer be an int. This may now be a string. Types have changed. We can't do that. The value gets thrown away. This is why leftovers are somewhat hated, because they do allow you to just kind of lose these values in between. There are functions which allow you to recover the leftover values. Most people never use them. In practice, this isn't actually that difficult of a problem to deal with. It doesn't crop up much. OK, we've now consumed 1. We've done our await. We've done our leftover. This is done. Map C is also done, because nothing else is consuming from it. So now we enter print C. Print C is going to await. It's going to come upstream. It's going to grab 2 and print it 3, so on and so forth. It's going to get to 10. Yield many is going to be done. It's not going to have any more values. Print C is going to be done. This component of the pipeline also exits. And now we come back downstream. Print C awaits. There's nothing there. And it exits. And that's the output. So we lost the 1. We started off with hello there. And that's the end of it. If that was confusing, I do recommend, actually, I have to be honest with everyone. When I was reviewing the slides earlier today, I actually had to stare at it and then run the program and make sure that I wasn't crazy about what it was going to print out, and I got it wrong the first time. So if you're confused by this, don't feel bad. One of the few things I can actually claim to be an authority on is Conduit. So if I got confused, everyone else is allowed to get confused too. But this is a really good challenge problem to make sure you understand all the different moving pieces. OK, yeah?
Sorry, can you clarify one more time why it's the right choice to throw it away?
We don't have another choice. Once we've gone ahead and we've gone through map, it could have changed the type of the input in any way in any way. So there's no way that we can take the values from inside and provide them back outside.
right back up to the yield menu?
No, because at this point it's been modified. Or, for that matter, this thing here could have done a leftover with a completely different value. There's lots of different things that could have happened here. So we can't even say, oh, well, one thing got leftovered, so why don't we like go back in our history and try to remember what we yielded? We couldn't do any kind of magic that would make any sense. The only rational decision at this point is throw away the data. The other possibilities don't have leftovers. But if you don't have leftovers, you don't get to deal with byte strings, and you don't get to do take while C. A whole bunch of things disappear. You lose a huge amount of functionality from the library, which is why they're in. Okay.
So leftover can only operate within its own segment of the file.
Exactly. Exactly. Leftover only affects other things that are monadically bound to it, none of the fusion. The fusion throws it all away. That's exactly right. Okay.
So the other library you mentioned also has some mechanism like this?
Yeah, they do it at a different layer of abstraction. So they'll have a different layer on top that has some way of dealing with the fact that you're going to have leftovers. Okay. And this is basically what we were just talking about. Now, you want to get started with this. How do you get started with Conduit? There's a number of different packages. The main one that you're going to want to jump into is Conduit Combinators. That's the one that's fully loaded. It's got the Conduit module that we've been dealing with. Just go straight for that. The Conduit package itself is lower dependency, and therefore it's more suitable if you are afraid of dependencies for some reason. And Conduit Extra is also lower dependency than Conduit Combinators, but it includes things like byte string and text, because we all know that the byte string and text package are really dangerous to depend upon. That's a joke. No one gets it. Okay. So I like the Conduit module. Some people prefer qualified imports. I don't. I happen to really dislike qualified imports all over the place. So I just add import Conduit. Everything is namespaced with the C or the CE at the end, so you don't have to worry about naming conflicts. Okay, we can all take a break for about 2 minutes, stretch, and then we're going to jump in. We're going to do Yesod. What?
Let's start with the right stack YAML.
We don't even need stack YAML. Every single one of these executables, these files, you copy into a text file, and then you just run it.
I mean, getting Conduit running, I did a stack install Conduit, and I just blew out my dot.
Run from outside of project.
Yeah, I'm not in a project. Is there a project to download? I blew away .stack and then stack install Conduit.
Use invalid package ID. Do stack upgrade. You did? What wait, stack dash version? No, you've got an ancient version.
Oh, really?
Yeah. Maybe your path isn't set up correctly.
Maybe I only did stack update.
That's possible. Yeah. Okay.
We don't have to go over right now.
What?
We don't
Yeah.
have to go over right now.
Oh. Good point. Get started? Okay, cool. So, what is Yesod? Yesod is a web framework, which might make sense because it's the Yesod Web Framework. That kind of fits together. Yesod is a web framework that supports traditional HTML sites and web services, generating JSON. You could generate XML or other things as well, but most people do JSON, and you're a masochist if you deal with XML these days. The goal of Yesod, the reason why I created it, the reason it's set up, we want to turn as many common bugs into compile time errors. As it happens, the examples I'm going to be using here don't actually demonstrate a lot of that. But if you go to the Yesod book, you'll see a lot of these examples of how we avoid bugs by avoiding 404s, because we're going to generate URLs in a way that it's guaranteed that the route actually exists or is valid. And we avoid cross-site scripting attacks and other such things. We're not actually going to be looking at too much of that right now. The general philosophy of Yesod is we want to do standard MVC-ish things. Django is actually probably the biggest inspiration, because that's what I used immediately before Yesod. Django Rails kind of stuff, and do it in Haskell. There are other web frameworks that are much more revolutionary. That's not Yesod. Yesod is boring. If you guys aren't asleep by the end of this talk, then you're special. Basically, Yesod is just a boring web framework. You need to get something done, use Yesod. You're not going to be particularly wowed by any particular feature. Yesod is built, yeah.
Would you recommend Yesod for a single page app where most of the action's going on in browser?
So it would actually, so I'm assuming there's also going to be a lot of interactions, a lot of other routes that are serving JSON from Yesod.
Yes.
Right. So let's knock it down one level. If all you had was, I'm serving up some JavaScript file and it's going to be purely client-side, never talking to the server again, who cares? It's just, it's static. So the real question is, would I do a JSON web service in Haskell, in Yesod? That's the real question. You'd have to look at the comparisons. Servant is very popular these days. A lot of people would use Servant. And I could get into a lot of the back and forth. If you're going to be using the Servant features where it's going to be generating client-side APIs, Yesod has nothing like that. So Servant's a really good choice for that kind of thing. So why would you use Yesod for this? Yesod has a lot more functionality built in. If you have any chance that you are going to need to also generate HTML, that also makes sense. It's got authentication support, session support, and the API is different. Servant has a philosophy of you need to capture all of the variables up front. You have to capture it all in the typed signature. Yesod is very hacky in that sense. You could just go ahead and ask for a query string parameter in the middle of a handler, and Servant wouldn't allow that. Is one better than the other? I'd argue that they're different, and some people like one and some people like the other. So if you're asking me personally, would I do it in Yesod? I would do it in Yesod usually, because I just want to be able to get stuff done. Okay, so Yesod is built on top of the Web Application Interface, or WAI, which is it's a protocol via types, but a protocol between web servers and web applications. Yesod actually has a reputation of this. Yesod uses template Haskell and DSLs in order to generate type-safe routes. It avoids a lot of boilerplate and avoids the possibility of people making a lot of mistakes. We'll see that in a bit. We have a handler monad that most of your code is going to live in. And this is the thing that's going to provide you with the functionality of looking up headers, looking up query string parameters, and a bunch of other things, redirects, a whole bunch of the different things that you would want to do when you're writing some code. It's got this widget system, which makes it a lot easier to generate HTML, CSS, and JavaScript. It's got a large number of add-on libraries. You can just search for Yesod in any stacked snapshot and see a huge number of different libraries. And it has tie-ins with the persistent library for being able to do type-safe database access. A lot of people ask, do you have an ORM system in Haskell? I wouldn't call persistent ORM, but it's probably the next best thing, the closest thing. You may even argue that it's the better thing than ORM, but that's a separate discussion. Yesod has a lot more flexibility than we're going to talk about today. It can do things in lots of different ways. I said that we have template Haskell. You don't actually have to use the template Haskell. You can just use Yesod as a library. You can swap out which database libraries you want to use. It's not tied into persistent in any way. We're going to use Warp as a web server to host this. You could use FastCGI. You could use, there's a few other things like YHandler WebKit, where it's basically old version of Electron, old way of doing Electron. And if you are interested in more of these kinds of details, there's a specific chapter in the book, Yesod for Haskellers, where it goes into more of these details. The Yesod book overall is written for people who are not expert Haskellers and they just want to get stuff done. That chapter in particular went the other way and said, you actually understand Haskell, why don't I give you a little bit more information? All right. The standard workflow that you would use if you were going to get started writing a Yesod application is you would type in stack new MySite Yesod Postgres or Yesod MySQL or one of the other different choices. That's going to give you built-in support for a lot of things. It's going to have authentication. It's going to have a config file that you're able to modify. And it has support for reading configuration out of environment variables. That's very useful, for example, if you want to use like Kubernetes for deployment, which uses environment variables for configuration. It's got HTML templating built in. It uses Bootstrap CSS out of the box. It's got logging. It's got CSS minification. It's got all these great things, and it works with Yesod Devel, which is a development server that will automatically recompile and relaunch every time you edit your code. So that's all great, and that's what I use when I'm actually writing a Yesod application. We're not doing that today because we're just doing shorter examples, and I don't feel like diving into a huge amount of code. Yesod is big, so Chris actually reviewed my Chris Nuttycombe reviewed my original slide deck and recommended, why don't you focus on something people are actually going to be interested in? So we're focusing on JSON web services instead of like HTML stuff, because apparently the world has moved on, and I'm sad about that. But if you want to read more, the book goes into many more details and is actually geared towards people who are doing HTML sites instead of JSON services. This is what most of our applications today are going to kind of look like. It's going to be this template. And now let's go ahead and look at all of these different things. Well, that's a lot of language extensions to start off with. And if you think that's a lot of language extensions, then you haven't seen a real Yesod project yet. So why are we using it? Well, if you use also, by the way, persistent will add in like 12 more language extensions, so just be ready for that. Overloaded strings, because everyone uses overloaded strings. We're always using, not string, because string is bad. Quasi-quote and template Haskell is used for the routing DSL that we're going to use. Type families are used for associated route types. I made a little comment earlier about type-safe URLs. Every time you have an application in Yesod, you also have a data type that represents all of the possible routes that you could have in your application. Yeah? Did you have a question? Oh, sorry. No implicit prelude. We're going to use classy prelude for Yesod for this. You don't have to use that. It just makes it a lot easier in these slides instead of having like 15 import statements. And view patterns is actually necessary because the generated code from the template Haskell uses view patterns. By the way, if you forget one of these, you'll just be told by the compiler that you forgot one of these. Okay, so we've got classy prelude. Whether you love it or not, it's there. Foundation data type. This is one of the core concepts that you have to know about Yesod. By the way, Yesod is a Hebrew word and it means foundation, so that's why we call this the foundation data type. Every single application in Yesod has a data type at its core. This data type is used for putting in config values or global values that you need to initialize when you start up your application. It's also used for a Yesod type class that we'll look at in a second. And you're able to get access to your app value inside any of your handlers using the get Yesod function. And that'll, so, actually we'll see an example of it. I won't go into more detail now. We're going to go ahead and declare the routes that exist in our application. We do that inside this here little block. You can treat that as magic. It's template Haskell and quasi-quotes put together. It generates the data type for the routes. It generates some type class instances for parsing and rendering those routes. This is a really good thing. Normally, you would have to write some kind of code that would take a URL and turn it into a data type, and then write some code that takes a data type and turn it into a URL. That's boring, that's boilerplate, and it's error prone. You change something in one place, you forget it to change in the other, and you've now got a bug. So this is correct by construction. It would be nicer if we didn't have to use template Haskell to get it, but template Haskell gives us this in a very easy way. Here's an example of what one of these things looks like. So we've got /home_r get. So slash is saying, what does the URL look like? It's just slash. It's the root of our application. Home_r is going to be the name of our application. That's going to be a data type, data constructor inside our route data type. It's also going to, and we put that r at the end. That's just by convention. There's nothing special about it, but I think everyone does it. And then we have get here saying which different request methods are we going to respond to. And in this case, we're saying we're just going to respond to get. If someone made a post request, we would return a 405 bad method status code. So these things are handled out of the box. This will generate code that looks something like this. It's going to generate a render route instance. Render route is going to declare an associated data type. If this is scary and you haven't seen this before, don't worry about it. It's just there. But we now have a home_r. And we will see that we also get other more complicated data constructors if we have parameters, but we'll see that later. And we get a function which is able to take that route and turn it into a list of texts, and that's how we end up turning it into a string and sending it out to the user as a URL that they're able to click on. Parse route just does the opposite. It takes the path and it takes the query strings and it tries to parse it into a route. We get this convenience type synonym. Handler is equal to handler t IO app. Oh, actually, it's handler t app IO. Sorry, that was That was a dyslexic moment, apparently. So those two things are supposed to go the other way. Handler T is a monad transformer. Most of the time, you're just going to see handler all over your code. This is where you got the handler from. And then we get an instance of Yesod dispatch, which I think I explain what that is on the next slide. It would be tedious to have to write all this stuff manually. You're not even seeing what render route, parse route, and Yesod dispatch actually look like under the surface. They're big, ugly functions, and they're written that way to be efficient, and we don't have to worry about that. The Yesod type class. Every single app has to have an instance of this type class. This is where we put settings for the way our application is going to behave. For example, if you want to have user session data, how are you going to do that? Is it going to go into a database? Is it going to go into a cookie? What's going to happen? So you can configure that here. The defaults that it provides are good enough for many cases. For the case of the sessions, it's going to go ahead and store it in an encrypted cookie so that the user is not able to modify it, but you're able to modify it. And then you don't have to deal with the database. You get automatic statelessness when it comes to sessions, which is kind of nice. The scaffolded site provides a lot of good overrides based on the way that the files are configured in the scaffolded site. That's a really good place to look. If you want to look at what are common things that people would modify, check out the scaffolding. All right, so let's say that we want to define our own handlers. You know, at some point we're going to write some real code, because so far we haven't actually written any code. We've only declared what our routes are. So let's say that this is what our application looks like. And I've been using fibs as an example all week. When you're talking to non-functional people, please never use fibs as an example. We're friends here, so we can talk about that. Fibs is never a good example because people hate fibs. But I'm going to use it on you guys because you'll put up with it. So here we're declaring a route home, just like we had before. We're also declaring a fibs route, where it's going to give you back the Fibonacci value at a certain index. Notice that it has this hash at the beginning and now a data type. What it's saying is, I am going to capture that value from the URL. And then, when we define our handler function, we get to receive that integer. And now we're able to actually give some kind of a response based on what the user put in the URL. That's kind of nice. It's also kind of necessary if you're going to do anything real. The handler names are just done by convention. If you have the get method on the fibs are constructor, then you get the get fibs are function name. If you don't like that naming convention, that's just a naming convention. There's nothing special about it. There's nothing magical. And then we run it. There's this warp function. Warp is a convenient helper. It does a whole bunch of things for us under the surface. It takes the app value that we gave it and it turns it into a Y application. And then it applies some middlewares, which do cool things like gzip compression. And then it launches warp. And that's kind of cool, and it's nice that we're able to use that. And if you want more control, you can do things in a lower level way with 2Y app or 2Y app plain. Just go read the documentation on them or look in the Yesod scaffolding, which uses them. The cool thing is, right here we're just doing warp 3000 app inside our main. We could have also done a whole bunch of other things. We could have read out a config file or anything else, put that into app, and then used it. And we will do that later. Finally, we're able to do hello world. What does it look like to actually run a Yesod application? So we have this route, and inside our handler, all we're doing is returning a text value. So we have to respond with a MIME type. How does Yesod know that this is text/plain? Who can guess where it got that information from? The type of the handler, exactly. The return type is text. Yesod will go ahead and automatically determine that it needs to do text/plain because that's the MIME type associated with text. Let's say that we live in the 21st century and we actually want to have more than text. Let's say we want to have some kind of JSON value. How do we do that? That is all. You can modify that trivially. Now this is from the ASON package. People who aren't familiar with it, don't worry about it. Value just means a JSON value. Overloaded strings is automatically converting this into a JSON value, and now we're able to just respond with that, and we have a JSON web service. That's it. We now have one. So I guess we accomplished the goal, and I have 20 more minutes to talk about whatever I want. But we have a JSON web service. And this will automatically now give an application/JSON MIME type. You also may want to be able to give both, because that's very useful. A client may want to elect to either get a text representation, a JSON representation, maybe even HTML. So you can do both in Yesod. We have this thing called select rep, select the representation, and then we're able to provide multiple representations. So we've provided both text and value, and whichever one of these matches first will be used. And if the user asks for an image, image PNG, we're going to say we have no idea what you're talking about. 406 not acceptable. We have no acceptable response to the request you've made. Yeah. Yes, it's looking. Yes, this is just looking at the accept request header. Anyone else? Okay.
Is there any way to specify the provided representations without doing any work first? So suppose you had to do some expensive thing to say go to the database and do something.
Yeah.
And then at the end you only provide a text and JSON response, but the user actually asks for a PNG.
Yeah.
So could I provide that, hey, I can do text and JSON ahead of time so that if the user asks me for some garbage, I don't have to go to the database?
You can't do that in HTTP. There's just you could do it with a header request. There are ways to do it with head. So yeah, you could provide a header request, and then the client would have to make a header request to see what you would respond to it. I don't think there's another. Just someone override me if I'm wrong. I can't think of another feature of HTTP. Say again? However, let's now talk about the other part of your question. I have this expensive thing that I'm only going to use sometimes. I'm not always going to use it. You could actually do expensive thing here, after we've already selected the representation. So expensive database call, and then return that. So for example, if your JSON is missing some expensive thing to calculate that your HTML needs, then do the expensive thing for HTML, don't do the expensive thing for JSON.
What is typed content?
Oh, yes. So so previously we had text and value as the return types. And those were able to tell us at the type level what kind of content we had. We can't do that anymore. There's no response here that will tell us, just by its very nature. We're returning both text and JSON. There's no type that says I'm returning one of those. Typed content says, I don't actually know at the type level what kind of type and this is getting complicated because it's content type and Haskell types, so the words are weird. But I can't tell you at the type level what content type I'm going to have. You're going to have to look inside of me. You're going to have to look at my value to see what kind of content it is. Yeah?
The style is very similar to Ruby on Rails. Was it intentional?
The witches?
The style of the programming.
Yeah, I tried more for Django because I was more familiar with it, but it was definitely inspired a lot by Rails.
And I know that if the config was using it in production,
yeah.
Are they still using it?
Yeah. There are. I wish we kept the pages up to date. There are a lot of companies that are using it in production. If you go to the Yesod Wiki, you'll see 5 companies that were using it, 7 years ago, but there's many more now, and I don't think anyone's keeping the page up to date, which is pretty bad marketing on our part, and we should fix that. Okay, so in addition to being able to determine the MIME type from the types, you can also give it explicitly. So here, we're going to say provide rep type, and we want to return a CSV. And notice that we're actually returning back a text value, just like we were before. But now, instead of it being treated as a text/plain, now it's going to be treated as a text/CSV. Okay, route parameters. So I already mentioned this before. We were able to capture a value that comes in on the URL. And then we're able to use it down here in our function. And now I'm going to use this. I'm going to actually ignore the get URL render for a moment. I want to return the value that the user asked for. So I'm going to go ahead and create a JSON value using the object function. If you're not familiar with the JSON API, you can look it up afterwards. It's pretty straightforward though. Creating a JSON object with a key called value, and the value for that is going to be the value of the Fibonacci list at that index. We also want to send in this JSON response a next value, which is going to be the URL for the next number in the sequence. And what we've done here is we've grabbed the URL rendering function, which will take our route data type that is automatically generated for us, and we'll convert it into a string. And then we're able to construct this fibs r I plus 1, which gives a specific route in our application, but it does it in a type-safe way. We can't accidentally misspell something. The compiler will check it. Then we use render, which turns it into text, and that text can get sent over the wire. In this case, in JSON, it can also be part of HTML if it's inside an href or something like that. In addition, in this little web app, we are starting everything off where if the client makes a request to the slash route, it's going to automatically redirect them to the first Fibonacci number. Questions? Yeah. Yes, yes. So could it be something besides an int? Could it be something more complex? The answer is yes. We have a type class called pathPiece. And anything which is an instance of pathPiece can be used here. And pathPiece says how you would render it to a string and parse it from a string. Cool. There we go. It's not too terribly technical. I mean, basically, in the pathPiece declaration, we define instances for all of the standard things you'd want. So string, text, not byte string, that wouldn't make sense, but a bunch of things along those lines. Okay. Query string parameters, also known as get parameters. So you are able to go ahead and just look up a get parameter from an index, and it may or may not exist, so it's going to give you a maybe, and it's going to give you that maybe back as a text value. And now we can just use normal Haskell code to go ahead and parse this out into an int. So we're going to take the maybe, we're going to use monadic bind, readme, unpack, and if you're not familiar with Haskell and monads, then that looks really scary, and we can look at that afterwards and talk about why Haskell's awesome. And then we're going to default from maybe, we're going to default into 1. And now we're going to use a different route rendering function. We're going to get URL render params. And this is going to not only take a URL that we're going to go to, it's also going to take a list of query string parameters. So now this is very similar to what we had before, but instead of giving fibs r a value, we are now making a query string. Index is equal to tshow of I plus 1. Tshow is the text version of show. And yeah, we can look up parameters easily, and we can also, there's also form support. If you're doing an HTML application and you want to build complex forms, there's a library that does that, and you don't have to get into the nitty-gritty details if you want something simple. Post parameters. These are things that get passed in on the request body. We can do those too. So now instead of a get request, we've changed this to a put request. This is using the put HTTP method. Notice that we've changed the name of our function to put fibs instead of get fibs. That's all we changed, and everything lines up nicely. Instead of lookup get param, we used lookup post param. And then we did the same thing, got the value, did not give back a URL in this case because there's no way to pass in a URL that includes a post parameter value, so there's no real way to do next in this kind of a setup. We can make a request like this. If you guys want to play out with it yourself, you can definitely do that with curl. And yes, even though it's a put method, post parameters just means anything that comes on the request body. So you're still going to call it post parameters, which is a little bit of a weird naming convention, but it's existed for a long time. Post files. Let's say that someone is going to upload a file to your web application. How do you deal with it? Well, then you just do lookup file. And it's going to give back a maybe value, so I'm just doing just here. And then, look at that, file source. Does that look familiar to anyone? This is to make sure you guys are still awake and actually still paying attention to what happened an hour ago. So, Yesod has built-in support for Conduit. You can use Conduit if you have any kind of reason why you have to do streaming. It's not necessary. I would say the vast majority of applications don't actually use the streaming stuff directly, but you can if you need to. So in this case, the user's uploaded a file. We are going to source that file, and we are going to find out how big it is. Notice we said length CE. that's going to find the number of elements, meaning the total number of bytes in the file. We're going to run it, and actually it's weird that I used res. We don't need res there, but that's different. And then we're going to return a JSON value saying the name of the file, the content type of the file, and the size of the file. Okay? If you actually want to look at everything that got uploaded as to the application, you can use the run request body, which will parse out all of the parameters and all of the files that got uploaded. Yeah?
Do you know if Servant has support for Conduit?
Not that I'm aware of, though you could probably add it on pretty easily since they're using Y, and Y has a package called Y Conduit. I can't guarantee that it's easy to tie it all together, but I can't imagine it's that difficult. Yeah.
Is it straightforward to host a servant app to handle some of the routes?
Inside a Yesod application? Yeah, we have something called Y subsite, and then you can go ahead and take any Y application and embed it inside a Yesod app. Okay. All of this that we were just dealing with, it works for form uploads, the kinds of things that HTML deals with, URL encoded data or form data. But if we're writing a web service, we're probably going to get a JSON upload. So there's support for that in Yesod as well, where we have this function called require check JSON body. Yeah, that's a long name. That require means that we actually need it to be there as opposed to getting back a maybe value. If it's not there, then it's going to return a 400 response. Check is going to make sure that the MIME type of the upload is actually correct. We had reasons why this was this is the right behavior. You don't want to try to parse a request body if the user hasn't told you that it's actually JSON. Ideally, this would be the name of this would just be the default function. It would just be require JSON body, but we have backwards compatibility to deal with. So this route is going to receive and upload a JSON body. It's going to parse it, and then it's going to return it back immediately. So it's a dumb server, and you can see that yourself. And this is going to use the from JSON instance. So if you're familiar with ASON, it's automatically going to parse it into whatever data type you want. We can also look up headers and send those back. So we can do lookup header, add header, Marco Polo. This decode UTF-8 in the middle, that's just ugliness. That's ugliness in the API. It's the fact that sometimes we have byte strings, sometimes we have text. It's difficult to deal with headers sometimes to figure out exactly what the correct data type is for that. The other nice thing is that case-insensitive lookup just works. Request headers and response headers are case-insensitive. So if you receive Marco capital M, this will also work. Permissions. Let's say that I want to let a user log in. So I'm going to have them put their password in the query string parameter. I'm going to look it up. Yeah, enjoy the example. Spaceballs reference if anyone doesn't get it. So you can go ahead and you can look this up. And then if the password is incorrect, 12345 is a great password for my luggage. If you have the wrong password, then you can use the permission denied function. And that'll send a 403 unless I'm getting my numbers wrong. Obviously, please, no one ever write a web app that gets a password on a get parameter. This is bad, but it's a good example. But let's do something a little bit. Oh no, we're still doing bad. Cool, we're still going to do bad. It's actually ugly that we are checking all of this authentication logic inside our handler. Imagine if we have 5 different routes that all want to be authenticated. This would suck. So let's do it the right way. First thing to notice, I've added this little bit at the end, exclamation point admin. This is a route attribute. I can add arbitrary words to the end of this line to add these attributes onto my routes. Now, inside the Yesod type class, you may remember I said that you could put settings here. This is the kind of setting you can put in. You can check whether someone is authorized to access a route. So here I'm going to do is authorized, the route data type, and is right tells you whether they're doing a GET request versus a POST or a PUT request. We don't care about that here. I'm going to check if admin is a member of the attributes on that route. If admin is in those attributes, then I'm going to do my lookup logic, check the password, and do the authentication and do unauthorized versus authorized. And now my route doesn't actually have to worry about anything because the authentication is taken care of elsewhere. We also have session values. I'm not going to go into too much detail about this, but now we're doing this the right way. You can look up a post parameter instead of a get parameter so that the user is uploading their password via form, and it's not going to just be broadcast in their URL. And then you can go ahead and set session to determine whether they're authorized or not. So we're going to do this inside post auth. User would make an upload there. And then inside the isAuthorized function, we would be able to look up the session value and check if they were actually authorized. We don't have to worry about the user like modifying their cookies to spoof us because we're actually using an HMAC to both encrypt and to hash the value that the user's provided to us so we know that it's not modified. In the real world, you're actually going to use some kind of pre-existing library. We have a bunch of them. I'm still very sad that Mozilla Persona shut down. I thought that was the best one that existed, but Mozilla killed it. Streaming request body. So you can go ahead and put all these things together with Conduit. Raw request body. We can parse the bytes, turn this into some XML stream, and then we can find out how many different events occur, like SAC style parsing like I was mentioning before. We can find out how many events occurred in that XML value body. And you can create streaming response bodies also. You can respond source. We're going to be doing a CSV file. And this is a real world example, not real world example yet, but it's getting pretty close. If you could instead pull the values out of a database, now we'd be talking. And of course you can do that with Yesod, but not in like a 5-line example. So we're going to go ahead and we're going to send a chunk downstream with the number and with the the header of the CSV file, which is going to be number and +1. I'm going to give out a bunch of numbers from 1 to 100, and what their value is +1, because I'm not very inventive. Going to loop through these, and then I'm going to yield a value downstream. And intdec, you guys probably haven't seen that before. Those are builder functions. They will take an integer, an int value, and give you back a byte string builder. And this is pretty efficient, but it's probably not a very friendly API that you want to play around with. So Yesod also provides some kind of helpers to just deal with text and byte string, which is what people are much more used to dealing with. So you can just send a chunk of text, and then use normal text functions like tshow, and send those downstream. Last example. We're out of time. Do you guys want to see that, or did anyone have questions they wanted to ask instead? Any questions? OK, so config file. People have to write config, and we're going to allow people to not only write their config in YAML, we're also going to allow them to override config values with environment variables. So we have this syntax. I think we stole this from Rails also. We're really good at stealing. So we have this YAML file, and we're saying AWS secret is a key here, and we want it to be filled in by the environment variable called AWS_secret. And there's no defaults at the end. By contrast, this home response value is going to come out of an environment variable, but if there isn't any environment variable, we're going to use this as the default. We're going to represent this with a data type called config that has these two values. And then this is just normal YAML parsing. We're going to parse that value out of the config file and fill up that config. We haven't said anything about environment variables here. We don't have to here. Inside our handlers, we're able to use getYesod to get access to that config value that we put inside our app value. And now we're able to go ahead and send the response value to the user. And in our main function, we are able to use load YAML settings args, which says load a YAML file which has settings which will include environment variable overrides. Don't give it any default file names. Make the user provide the file names when running the executable on the command line, and use any environment variables available to override values, instead of, say, having a built-in set of environment variables. And then we're able to provide this value here and run our application. And you can see this is what actually happens when we run it. If we don't provide any environment variables, if we don't provide a config file, we get an error. And if we provide the config file, but we don't actually provide the AWS secret, we also get an error. Only once we provide the AWS secret are we allowed to run it, and we're also allowed to override the home response.
The reason
I don't know why. You know, it should be able to. There's probably a bug somewhere. It's probably not interacting nicely with ASON. It's pretty obnoxious. You can learn more about Yesod at yesodweb.com. You can look at the Yesod cookbook, which has more examples. And then 2 common code bases people like to look at are Haskellers and yesodweb.com. They're available there. Okay, that's it.